Hello, welcome back. This is Jeff Byers and this is Andy255. We're going to finish up our water fountain simulation in this video. I believe this is video part 5. So we have, let's take a look at what we have so far. Now if your gravity reacts a little differently than mine and it doesn't fall as fast or the speed isn't the same, it might be because your scene is either bigger or smaller than mine. I mean your scene size, how big your model is in your scene is a big deal. You can see basically here's the grid, the default grid for centimeters, so you can see that I'm a little bit larger, and if you want to get the exact same results you're going to probably want to scale your scene about the same size as mine if you want to get close to the same results. Okay, just keep that in mind, okay, because scale has everything to do with the dynamic size. So if you see my radius here is at 0.15 and your scale's a little bit off, it's because of the scale of your scene. So just keep that in mind and make adjustments. So it's not a big deal, just need to make adjustments, small adjustments to the scene scale size difference between mine and yours. Alright, so we have a blobby surface. We haven't used that yet. SW just basically means it's a software render, which is great. The rest of them are hardware renders. Okay. Now Arnold does not support, as far as I know now, I think maybe they made changes at 2020.4, and I have that on my new computer, but I don't have it on this one. And so I haven't tested that yet. I don't know. They're making adjustments, and I think they made adjustments to the particle systems. And they've been a little bit slow on getting the GPU rendering to work properly. So hopefully that I'm going to be experimenting with that this summer and doing some tests. Right now I'm using Redshift, which is super fast and very accurate, and they seem to have it down. V-Ray is really good with GPU rendering now, so they got a kind of a leg up that way. But I think Arnold will be in there in the next 6 months and do just a really good job, and I'm going to stick with Arnold since it's free. Some of you have V-Ray. Feel free to use it. I don't know a whole lot about V-Ray. I know it's probably as much as you guys do, but I don't really use it. So in my productions, but it is fast. It seems to be faster. I don't think it's got any better results, but I think it's faster as far as rendering goes, for sure. And we've got Cloud software render and Tube software render. Okay, so we're going to use blobby surfaces because I'm going to do something interesting for you guys. We'll get a closer result to what water really looks like. So it'll be fun to kind of mess with that. So I'll show you how to do that. Alright, so it's not as good as volumetric water, fluid water. So Bifrost will be the closest that we'll get out of Maya, and Real Flow is probably one of the best I've ever seen. So then we've got the plugin from school, which I haven't figured out how we're going to get that at home and give it to you guys, so that costs money. It runs off the V-Ray, and it's been so long since I've used it, but when I was using it was really, really good. But I'm trying to find something that will render as a mesh, and I believe Bifrost does that, but it's not as clean. But we'll look at that. And so what we're going to be looking at Bifrost a little bit later, because it's very intensive, GPU intensive, so some of you may have issues. So I'm going to have alternate assignments for those of you that cannot run Bifrost, and that'll be just fine. And I think we all understand and agree that that's what I had to do online. So we'll just have to deal with that. Alright, so with that said, we're going to continue on with this. So we need to do a couple things. We need to do the particle shape, and we need to make sure that the lifespan is not live forever. But we want to do random range, okay? So that's one of the biggest things we need to do is get that set up. And that's way too short. So lifespan should be around, I think we're at around maybe 4 to 500 before we even get to the bottom tier. So we need to get that set up. So let's do something like 6. Let's see where we're at with that. Okay, that looks pretty good. Again, we don't need to have it go, we don't need to have it rolling around, right? When it touches the bottom, we want to get it set up to where when it touches the bottom that we are good to go the minute it touches, so we'll get as close as we can to that. So randomize factor, maybe 0.5 would be good, and let's do a 5.5 lifespan on that and just kind of see where we're at. I think we're pretty close with 6, so just kind of, okay, so it's still a little bit long, so we can just do 5. A lot of this is just tweaking out. Okay. Alright, we're just almost there. 4.8. That's pretty good. I think that'll work. Alright, awesome. Cool. Alright, so my second, the thought I had was we could take the a couple ways we could try and experiment, but we could take the particles as they're colliding with the top tier and create splashes. That would create more water, and then when it hits to the other tier, we'll crash, you know, and split up into smaller particles. You know, I thought about that, and I thought, I don't know if that'll work, but it's something we can experiment with for sure. But let's just get this to a point where we can get it to render instead of spending a whole bunch of time just experimenting. But I'll leave that up to you guys, you know. But what I would do is go ahead and save your scene in a sequence. Okay, you can see how I'm saving this. I'm just adding the next sequence from 03 to 04. So I'm doing that as I go along, and hopefully you guys will do that as well, because I like what I've got so far, and I don't want to have to restart it all over again, okay, from scratch, meaning I don't want to go from bare model and then set up an emitter again. So I'm happy with what I have, and I can make little changes as we go along because I'm saving in a sequence. Okay, if you guys save over your scene, okay, each scene, you have nothing to go back to, okay, because it overwrites it. That's a really bad and poor way to manage your scene and to work. That's really a poor way to work. You always want to save in a sequence. It's going to save you. Okay, after you saved your scene, now we need to go on to think about what we need for this particular assignment. So I need to have a PlayBlast movie file that is compressed at XVID or H.264, and then I'm going to need to have at least the very minimum materials placed onto your objects, and hopefully that you'll have textures. I really want to see texture on at least texture the water fountain. Okay, alright, so that's the minimum. and we'll leave it at that. I hopefully you guys will go above and beyond and add textures to the whole entire scene. I do want to see a backdrop on the scene, which is just basically an image in the background, and the foreground you're going to complete just a small little scene that basically encapsulates what you see here. Okay? Alright, so with that said, let's go ahead and start thinking about what we're going to do for the rendering. So I need a play blast, and then I need one render, and that could be at the very end. So you'll play your entire animation, and at frame 1000 you're going to render that out. So how are we going to do that? So let's go ahead and take you through that. Alright, so let's go ahead and start adding materials. So we're going to use the software render, so let's get that set up first. Alright, so we're not going to use Arnold renderer for this. We're going to use the Maya software renderer. And under the Maya software render, we want the highest quality. Okay? And we want quality to be production quality. So production quality and anti-aliasing to highest quality. And we want the pixel filter to be Gaussian. And ray trace quality, we want ray tracing on. That gives us reflections, refractions, and shadows. Motion blur, we definitely will do that. I don't think we're going to do 3D, but we can do 2D. We can play with that a little bit. Let's take that, turn that off. That will slow things down, but it will make things. If you are going to animate this, then I would highly recommend turning it on. We'll look at it a little bit later. Okay, we'll leave it off for now, but I want you to know where it is. And then under render options, I don't think there's anything in there we need to really worry about. We're not doing any fog. So go to Comments tab. And in here, we're going to go ahead and set this up at JPEG quality. And there's going to be a way to set this up for animation, and I'll do that at the very end of for the extra credit. I'll show you how to get that all set up, but right now we'll skip that. This will just be for the single image that I want you to turn in. Renderable camera will be the perspective, and the presets will be HD 1080. We want this fairly large since we're only doing one image. And that is it. So that's all set up. Okay. Alright, so the next thing we need to do is we need to set up our lights. Okay. So we're going to go to Create Lights, and we're going to create a directional light. And that's the first thing we're going to do. Okay. Now, just like the sun, we're going to have the sunlight, directional area where the sun is actually coming from. That's going to give us all the shadows. Okay, that's going to be essential. So I'm going to rotate down. Basically, a 3-point light system will work just fine. Alright, so basically we're going to have the sun coming in from this angle. Okay. And I'm going to I have the camera basically in the Z, looking straight down in the Z, so you can see where that is. So there's that light source there. And if we look at the light source, its intensity is at 1, which is fine. Shadows, go ahead and open that up, and we want to roll down to use Retrace Shadows. And the shadow rays need to be higher than 1. We need to go somewhere like 4. Okay, shadow rays, and then ray depth limit at 4. Okay. Alright, so with that done, alright, so what we're going to do now is we're going to go ahead and copy this. So we're going to go Control D. Now I'm going to go to the top view now. Okay. So here's our light source. Okay, let me make it a little bit bigger. It won't hurt anything. And I'm going to go ahead and move that over. Whoops. Need to copy it first. Control D. There we go. Alright. I guess we got 2 lights in there now. I don't want to do that. Made a mistake. That's really small. Can't hardly see that. So this is the key light, and this is going to be our fill light. Okay, you got to have a fill light in your scene. So I'm going to go ahead and rotate that and get that rotated down like that. Go to perspective and kind of see where that light is coming from. Okay. Alright, so I might even rotate a little bit more like this. Okay. So that's more like straight ahead. So it's going to fill in all the shadows in here, in that area there. Basically to counteract this shadow, the strong shadow, that this is what's happening with that. Okay, all right. So something like that would work. And it doesn't matter where the light is, a directional light is in your scene. It's not like a point light or an area light. This can be, it's just the direction, the way it's rotated is what matters. Okay, and then we're going to take that and we're going to go in here and turn off Retrace Shadows. We don't want any shadows on at all. Okay, so the intensity will be just about half, about 0.5 on that. Okay, and then we're going to go do a Control D and we're going to move that in the back, and this is going to be our backlight. Okay. Alright, so we got a light coming in from this direction, a light coming in from the side, okay, and then we're going to have a light coming in from the back. Okay, so we're going to rotate this and move it down like that. So we're going to get some highlights from the back on this side. Not a lot, it's not going to be strong. It's going to be coming in from that angle there. Okay, which is fine. And we're going to do no shadows on that, and we're going to turn that down about half of that, so 0.25. Okay, so this is going to give us a well-lit scene. Okay, now we can tweak it out. This is just the beginning of it. Alright, so let's go ahead to hit the 5 key and we'll start from the top. What are we going to do? Well, let's do kind of like a ceramic water fountain. Okay, so I'm going to hit the Q key and I'm going to right mouse button over it and go all the way down to assign new material. Now, since we're using software, Maya software, we're going to click on Maya and we're going to click on Blend. Okay, and automatically it's going to give us a real shiny object. So let's go ahead and give it a color. I'm going to give it just a kind of a brownish color, earthy tone. I'm going to do that for all the other pieces. So it's basically a ceramic. Okay, I'm just going to use materials for now. I would like you guys to try to go into Substance Painter and give it some texture. That would be nice. That'd be great. So I'm going to continue down. Should be very simple, just as an example here. And I'm going to turn that color into a name. So let's call that platform texture. Alright, and let's just use that all the way down. Assign him existing material, and let's do that really quick here. I might even be able to just hit the G key. Yeah, that works really fast. Okay. Alright, great. Alright, so that's got one material. Then we're going to have the water as one material. So I'm going to go ahead and add a new material to that. That's going to be a blend. And it's going to be water. So let's go ahead and do an aqua color. I've already got stuff set up in here, as you can see. Just kind of an aqua color. And we're going to go into transparency. Add a little transparency to it. Ambient color, no. Incandescence, no. Diffuse, that's how bright it will be. I want that to be bright. Translucence, we don't want to mess with that too much. Eccentricity is how the light will react to it. Okay, so you can look at this. We want kind of a fine, we don't want it spaced out. We want a really flat, very hot specular color on that. Okay, reflectivity, that's good. 0.5 is good, and that's going to reflect the blackness of the scene, so you have to be aware of that. And a reflective color. Okay, now notice we don't really have any IORs. Now we do have refractions. Okay, refraction index, that's what we had with Arnold. That's called the IOR, index of refraction, and this will be, water is 1.33. Okay, and refraction limit is how many times the light will bounce away or bounce through the water. Okay, And surface thickness, we're just going to leave it the way it is right now, and we can mess with this later. Reflection limit, let's just turn that to 2. Okay. I think that looks pretty good. And that is going to be called water. Okay, great. Alright. And we will just go ahead and add that. And then this should be easy now. Now we can hit the G key because it remembers what we did before. There we go. Awesome. So let's go ahead and get it kind of set up where we're going to see it. And let's do our first render. That should be 1080, which I could probably, if we're doing like regular just plain previews, we may not want to go this high. So the reason why it's taking so long is because refractions and reflections take a while to render. And we're never going to get a photorealistic render out of a software render. That's never going to happen. But it rendered pretty quickly, actually, a lot quicker than I thought. Okay, so we got quite a reflection here, and you can see the reflection in the water. Okay, that looks pretty good. It's pretty decent. It's not perfect again. And shadows look okay. Couple things we can do with that, probably make it a little better. Okay, but that's good so far. Let's take a look at the water. I'm going to close that, and I'm going to go back into the render settings, and under Comments tab, I'm not going to go with the highest render solution right now as far as resolutions goes. Let's go with 540 so it'll render a lot faster. So we got ray tracing, refractions, so that's pretty decent. Let me look at anything else I can find. What else do I have in here that I need to take out? So at the very bottom I see render options. My software comes with an enabled light. Now, I haven't used SoftwareRender for a long time. I only use it for particle simulations, but I do know that this is on, so that might play a little factor in why it's so bright. But I'm gonna go ahead and turn that off, and then at that point we don't have any lights going on. Okay, so I think that will work just fine. Let's go ahead and do a render now of that. Okay, I'm not crazy about the shadow. It's pretty straight. Usually shadows kind of taper off. They're pretty sharp at the beginning, and then what happens is that it diffuses out as the shadow goes out. So that's usually normal. So how do we do that? There's a let's go into render settings again. Oh, let's go into the light. That's where we need. So let's go into the light source, and in here you can see shadow rays, a light angle. Okay, that has to do with how far it will go before it does a diffuse on the shadows. So we have it set at 0. So let's set it at something like 1.2. We'll soften that and make it look a little more. Oh, that's not what I want to do. Look a little more realistic. So let's go ahead and render that out. Okay, so you can see it getting a little more fuzzy in the background there. That looks a lot better. Okay. Alright, so let's go a little bit more with that. Select the light again, and let's go to something like 1.5, and then shadow rays needs to be turned up a little bit more. So let's go to something like 5, ray depth limit at 5, and then shadow rays, let's go into the my software part. And you can see reflection and shadows. Let's go to 12 on that, and that's going to give us a better result. Okay, Alright, so now let's go in here. I think we're good. And let's go ahead and render one more time. Get a little closer this time. Get a full view of this. And render it out. That's going to take a little bit longer this time, but not too bad. Okay, and we'll zoom in a little bit, and that's not so bad. That's not too bad. Okay. Alright, great. Right, so now we need to think about the water coming out. So let's go ahead and do our simulation. And I'm going to get closer this time. And we're going to apply this. Click on the particles. Let's go into the particle shape. And in here we have, I'm kind of scrolling down to radius. Now we did radius, and I'm going to do a render here real quick just to kind of show you what's happening here. Right now it's going to render those things to look like marbles or gumballs, so we don't want that. Okay, so you can see that we've got shadows going on in the scene, which is good. Okay, so I'm going to go ahead and we're going to pop that in. Alright, so we're now going to add that water. Okay, I'm going to save the image. Okay, I'm going to move that over here like that. So I'm going to click on that, and we're going to add that existing material, the water. Okay, so let's go ahead and do a render, quick render here. Okay, so you can see that reflection is causing this, even though that's the same material, the reflection is causing it to look like bubbles, right? Okay, it's streaming across. So that can be an issue or a problem, but you know what? We're not going to get too crazy about it because we're trying to make particles look like real water. We're going to get to a point where there's only so much we can do. But let's go ahead, and there's a function in here though called threshold. What this does allows the two particle systems to see the actual radius of each other, and the minute they touch each other, they coagulate. They kind of explode into each other. They kind of mesh with each other. And just, as you can see, nothing like that is happening. So let's get a little closer so you can see a little bit better. Those still are separate, looking like marbles, and even though they're kind of colliding into each other, they're not absorbing each other. Okay, so keep that in mind. What's happening here? I'm going to go ahead and put that into the image, and what I'm going to do is I'm going to turn this up 2.5. Okay, I'm going to play the simulation again. Okay, and it will give us a little bit of a different result here. Let's go to 1:1 again, and let's go ahead and render that out. But we're going to see the particles kind of, they get smaller, and then they start going into each other and absorbing each other. So you can see the difference here in a little bit. Okay, so now you can see that they're smaller. Let's take a look. What they were before, and this is what they are now. Okay, so that makes a big difference. Okay, so the issue now is that they are absorbing each other. You can see that a little bit right in through here. Okay, they're starting to coagulate, become like one object. Okay, that's what we're looking for. So we're not quite there yet. Let's go ahead and go to 1:1 and put that in. And then what we're going to do now is change this to 0.8. That's about as far as we can go. Okay. And because that every time we go up with the threshold, we need to turn the size up higher with this. Let's do 3. Okay. We're at 0.15, and now they're about they're going to be about twice as small. So that'll bring that radius back up again. Let's go ahead and start the animation again. And so they look really big there. Okay, so let's go ahead and put that in, and let's do another render and see how that looks. And now we should have something that looks a little more realistic. Nothing's going to look as good as volumetrics or daemons. Now, real flow, there's a lot of, oh, there we go. But we're getting close. See how they're coagulating with each other now, see? Okay, and that looks much, much better. A lot nicer. Yeah, I like that. So all we need to do now is to go ahead and add more. We need to add more. We're not even close to having enough. So this is where it gets a little crazy. To get as much as we need, your systems might have a problem. Okay? So you go as far as you can. I'm not going to count off because you can't go far enough. I'm only going to count off if your renders don't show this type of stuff going on. Okay? Okay, if I see a render like this, that means you just didn't do your work. Okay? But if I see a render like this, okay, I know you did your work. But the thing is, I know and understand that you couldn't do more than that because your system couldn't handle it. Okay? So, alright, cool. So now, let's see. You know, my system's a little different. I've got a 1080. It's an older card, but it's really pumped things out pretty good. Here we go. Alright, just not enough. So if we look at this, we render one more time. Get close enough here. We'll render one more time here. We just don't have enough to look like water. Okay? And that's the issue, is being able to do enough to look like there's water. There's water there. So we'll just have to check it out here and see what happens. Now the closer you get to this, the longer it takes to render. The farther away we get, the better it will be. We're super close. So, you know, when you look at this, it's not going to look realistic, but far away, it looks pretty good. I'm going to go ahead and pause. Well, there it goes. It goes quick. There we go. So you can see we have a lot more. Okay. All right, great. So the next thing we do is we go into the emitter. So Windows, Outliner, and we go under the emitter. And in the emitter now, we're going to go in here and add a 0. Okay. So that's going to be a ton more. Okay. Now we can back off a little bit and check out what we have. Okay. Okay, so we see things disappearing there. Now let's stop it and go ahead and render that. Okay, and this is what you'll be doing for a while. You play a little bit, and you'll see how far you can take your graphics card. And don't worry that if your graphics card, if it's chunking away, as long as it doesn't stop or crash, you're good. So once you get through the whole thing, you may have to let it simulate to the end, but you can then yeah, see, that looks much nicer. See how that's looking? And it looks like real water drops. It's like real water coming up and then spreading across, and you know, it looks great. So it's just, you're just not even, there's not enough. There's not enough particles yet. So we'll put that in, and now we're gonna go. I'm gonna add one more 0. Okay, 10,000 polygons, or excuse me, 10,000 particles. Okay, let's let it go for a while. Right, so they're dying off. Okay, and I feel pretty comfortable even going higher. Wait a minute, my rate particles, I didn't do it the right way. I needed to add a 0 here. It's not quite 10,000. I did it at the end. There we go, 10,000. Here it is. That's it right there. Awesome. Now my card is even running slow. It's at 10, running at 12, 10. It's not running fast enough, right? But if I go in here and do a play blast, it will render in real time. As long as I can get through, you know, the simulation, through the whole thing, I'm good. Okay. Now we get to this point, it's just gonna chug along throughout the whole thing. Okay, I'm gonna stop it. Let's do a render. 10,000 is about all I can do. I don't expect you guys to be able to do much more than that. If you can do 5,000, that would be great. Just do what you can. Okay, and then let's take a look at what we have here with the render. Now the render will take longer too, because I've got 10,000 particles, way more than that. That's 10,000 per second. So before it dies off, I think I got so I've got 60,000 particles that it's got to render. So it's going to take a while. So I'm going to pause. Okay, so that took a lot longer, about 4 minutes and 40 seconds. But that looks pretty good. Pretty happy with that. It's not perfect, and it doesn't look exactly like water, but we're getting close. So you can see that even on a powerful computer like what I have, it took about 4 minutes 40 seconds. So I'm not sure how long it'll take for you guys, but you better give yourself at least maybe an hour or two to render that out at full resolution at 1080. Okay, so here's some other things you can think about doing that can help a little bit. I'm going to go ahead and turn that down to back to 1000. Okay, so I'm going to go back to simulation and just do a quick simulation with 1000. There we go. Okay, so what I'm going to do now is get a little closer to the particles. Okay, I'm going to go into the render settings, and I'm going to experiment with motion blur. Now motion blur, as you guys know, when you take a shot, it has a lot to do with shutter speed. If you take a shot of water, and the higher shutter speed you have, and the more light that comes in, that it will stop the particles in mid-flight, meaning like when you see water running, you don't see those little particles of water. Now in CG, it's the other way around. You will see those automatically when you render, so you have to actually add motion blur to make it look like water, like it's really running, especially when you do an animation. So that's why it looks so funny. Even when your animation, it looks like little round balls, and motion blur will help with that. Okay, so blur by frame. So let's go ahead and take a shot of this first. Okay, now what I'm going to do is I am going to keep it as is. We got it on very low. This may still take a while to render, so I'm going to go ahead and click on it and then stop the video, and then I'll come back. Okay, as you guys can see at the render, it's only 30 seconds. It took only 30 seconds to do that, and amazing enough, it's because I only had 10,000 or 1,000 particles per second. So I'm going to go ahead and pop that in, save the image, and I'm going to render now with motion blur. Okay, I'm going to keep just the default settings, okay, and see what we get. See if that helps. So I'm going to go ahead and render again. Okay, so we're back, and the motion blur 2D, blur by frame, and length is 1. It has everything to do with how fast they're moving. And they're not moving that fast, so we get a little bit of a blur, and that's good enough. So just basically we want to get your full, when you do your render, make sure your background, we can see your background. Okay, so get a full frame of your scene, and I would suggest using, turn on your gate. Okay, alright, so you'll turn on your gate, and we'll get your whole frame in there like that. Okay, something like that would be good, and go ahead and you render that out with your motion blur. And that'll take about 30 seconds. Maybe it's going to be a little faster. There it goes. Okay, you can see that the blur is working pretty good. Okay, great. Alright, so you should have a lot more particles, so I'm going to go ahead and get that set up now that we know that's working okay. Let's go to the emitter, and let's go ahead and put that other bit to 10,000 again, and let's take a look and see how that looks. And we're not going to let that run all the way through. We don't need to. And then we'll go ahead and do a render of that. Okay, that looks good, and we're about as far as we can take it with the motion blur. And it adds just enough. And I think motion blur adds a little bit more realism, breaks up that some of those rows that you saw before, perfect rows. So that really helps. This is now just a preview render. You're not going to be turning this one in, unfortunately. So what we need though from you is your full scene. You need to have your entire environment in here, and I will take you through that. Basically what mine will look like. I'm not going to have a video over that. You're going to need to have everything in there, and then you can go to settings preferences. This is going to be your last video. Settings preferences, and you're going to set this up to HD 1080.